Welcome. This is Trig Ratio Word Problem Lecturing. Here, the learning target is for you to understand how trig ratios are applied to real-world problems. Your three success criteria is 1. Can you draw an angle of depression and elevation picture for a problem? 2. Can you solve for an angle of depression and elevation using your inverse trig ratios? Then lastly, can you use and apply the angle of depression and elevation to solve for a side of a right triangle? So let's review our vocab here. So we saw that they are the angles of adjacent, and your opposites will change depending on what angle you're looking for. So if you look at angle, if you're looking from angle A, the adjacent is going to be the blue line here. But if you're looking at it from angle B's point of view, the green line would be your adjacent leg. So please understand that your adjacent and your opposite legs will vary depending on the point of view of your angle. So let's take a look. The angle of elevation is from the bottom looking up. So the angle of elevation is like this person right here, and they are looking up. The formal definition is the angle of elevation is the angle between the line of sight, which is right here, and they're horizontal when an observer looks up. Line of sight right here. The angle of depression is, let's say the person here is on top of the lighthouse tower and they look down, and this is the angle of depression. It is the angle in which the line of sight when an observer looks straight downwards and horizontal. An easy way to remember this is that if what you're looking straight at is called the horizontal line, if you're looking down at this dog, which is going to be the depression line, which is down, right? And if you're going to go up, right, that is going to be your elevation, like looking at an airplane, right? That is in its most simplest form. Let's look at the vocab check. Now, you're going to draw the image and name the angle of depression and elevation. Here's the solution. The angle of depression is angle P, because you draw this person here. They are looking straight down. So this is going to be the angle of depression. But if we're looking up, like someone on the bus, and they are looking up, we call that the angle of elevation. So we call angle B is the angle of elevation. So let's see how a problem works now. Example 1. Find the angle of elevation. A pilot is taking off from a runway and needs to clear the peak of a mountaintop. The peak of the mountain is 225 meters away with an altitude of 400 meters. What is the angle of elevation B for the takeoff to clear the peak of the mountain? Round your answer to the nearest tenth. So here's the picture, and we're looking for the angle of elevation. So it's this angle. I don't know the angle, so I'm going to use theta. Theta represents an angle measurement. That's what we use for it. So we need to use one of our trig ratios. So from the point of view of theta, we saw that 2025 is our adjacent, because that is our closest one, and 400 is our opposite. From here, we notice that it is TOA, because TOA is your tan, opposite, and adjacent. Therefore, our solution is going to be tan theta is opposite over adjacent. We plug in the values, but I want to get theta, so I use the inverse. So theta is equal to the inverse tan of 400 divided by 2025. Now I pull up Desmos. Here's Desmos. Make sure you hit the function to get to the inverse sign. Tan inverse 400 divided by 2025, get 11.17, or you could round that roughly to 11.2. That is the angle of elevation. Let's now look at the angle of depression. A lighthouse is 110 feet above the sea. It can cast a beam of light which is 148 feet straight down towards the boat A here. What is the angle of depression from the lighthouse point of view? The angle of depression is this theta here. We have this triangle. We have 148 as the hypotenuse. We need to know these two sides. We know that this is also 110 because it's just a triangle after it gets reflected, and this is your opposite. We know opposite and hypotenuse is going to be your Showa, which is going to be your sine, opposite, and hypotenuse. So here, sine of theta is equal to opposite over hypotenuse. Our opposite is 110. Our hypotenuse is 148. I'm trying to get the theta, so I use our inverse sine. So theta is equal to the inverse of sine, 110 divided by 148. Plug that into Desmos. Sine inverse 110 divided by 148 gets me 48 degrees. Theta is equal to 48 degrees. That is the angle of depression. Here are your two problems that you should practice. Please pause the video and give this a try. Number 1 asks you for the angle of elevation, and number 2 asks you for the angle of depression. Let's go over it. Number 1. A golfer wants to know the angle of elevation of the ball that he hits into the golf hole. He knows that the ball travels 81 yards in the x direction and 36 yards in the y direction. So let's label it. I want to find the angle of elevation, so it's this theta. Label what you have. 81 yards is your closest one, so that is going to be your adjacent, and 36 degrees your opposite. Opposite and adjacent, that is going to be your TOA, which is going to be your tan, opposite, and your adjacent. Again, I do these steps every single time because that helps me stay organized. Here's my solution. Tan theta is equal to opposite over adjacent. My opposite is 36. My adjacent is 81. Plug that in. But I'm trying to get the angle, so I use the inverse. So the inverse tan of 36 over 81. If you plug that into Desmos, tan inverse 36 divided by 81, you get 23.9, which roughly translates to 24 degrees. Number 2, a boat can track sea creatures on the bottom of the sea floor by shooting lasers at it. The boat can shoot a laser with an unknown angle of depression towards the floor that travels 117 meters. The boat is 40 meters above the sea floor. What is the angle of depression? It's this angle here. We should label our parts. 117 is our longest side, which is the hypotenuse. 40 is right here. It's on the opposite side. So we have opposite and hypotenuse. That is going to be our Showa. Showa is your sine, O is your opposite, and H is your hypotenuse. So plug that in. Sine of theta is equal to opposite over hypotenuse. The opposite is 40. The hypotenuse is 17. I'm trying to get the angle, so I'm using the inverse. So it's the inverse sine 40 divided by 117. You get what? Let's grab Desmos. Sine inverse 40 divided by 117. I get 19.9. Roughly translates to 20 degrees. So our two questions here, we were using our inverse sine to solve for the angle of depression and the angle of elevation. Now you're going to find the sides. Okay, give this a try. Let's go over it. Number 1. All right. Okay. So I have the solution shown. Okay. You have theta here is 12 degrees. Please understand that you can mirror this triangle this way. So the height here is still 150 feet. What you have here is you're trying to find the height. You're trying to find this part here. Okay. So you're trying to basically find this, the x. Okay. Which is also this. So what you have here is your 150 is your opposite, and your adjacent is your x here. All right. So you're going to end up using your TOA because this is for tan, O is for your opposite, and A is your adjacent. Plug that in. Tan of 12 is equal to 150 over x. Multiply x to both sides to cancel it. Then you get x tan 12 equals to 150. Divide tan 12 to both sides. You get x is roughly 705.7 feet long. Next, 2. You're looking at it from the student's point of view. The student looks up at 27 degrees. They saw that the bus is 97 feet away. You're trying to find the height of the tower. I'm going to use the letter H for height. What do we have? Well, we have 97 feet, which is our closest one. This is opposite. No, this is adjacent because it's our closest one. And height is our opposite. So adjacent and opposite, that is your TOA, which is going to be your tan, opposite, and adjacent. Plug it in. I get tan theta is equal to opposite over adjacent. I know that my angle is 27. My opposite, I don't know, it's H, and my adjacent is 97. Multiply 97 to both sides because, again, that's divide by 97. So multiply by 97 to both sides. H is equal to 97 times tan 27. H is roughly 49.4 feet high. So there you go. Those are all your solutions. Here I want you to understand that you have to use your trig ratios interchangeably. So here we use our regular trig ratios to find the side. We use our regular trig ratios to find the sides. Okay, but we use our inverse to find the angles. All right, there you go.